Guten Morgen. Guten Morgen. Hello, I'm good. You?
Good.
Looks nice. What does it do?
Yeah, that's just chemistry.
Okay. It changed colors.
Yeah, actually I'm trying to do some cocktails which change color when I put this chemical ice inside.
That's amazing. Can you just tell me in a couple of words how does it work?
Yeah, so in fact this ice is not the typical ice that you can find in your fridge or in your freezer. In fact this ice is made of CO2. You know this CO2 is the gas that you expire.
I mean carbon dioxide, right?
Yeah, carbon dioxide, right.
I've heard of that.
And how we make this ice, basically we cool down to minus 80 degrees, so around. And when you cool down this carbon dioxide, so we got this ice.
Okay, that looks nice. Minus 80 degrees, that's literally cool, right?
Yeah, it's nice.
Amazing.
And in fact, what happened with this cocktail, so we have some acidity indicator in this cocktail, and we put this dry ice, so it will acidify the solution, and that's why it changes color.
That's beautiful. But now I'm curious, do you have maybe other experiments that I could see?
Of course, yeah. For example, what's your favorite color?
Well, my favorite, blue, of course.
Blue. I should have something for you. Yeah, here.
Oh, it's a bit blue, but not completely blue. Does it look very, very blue to you? No. No? No, not very.
Wait a moment.
Okay. It looks very chemical.
I just added a bit of this powder.
Nice.
And some water inside.
I really love turquoise on the top of that.
Of course, you have to mix each cocktail.
Yeah.
Then they're better.
Very blue. But you know what? I like my cocktails with a bit of milk, you know, a bit more like milkshake.
Some milk. I don't have milk here, but wait, I think I have an idea. If I put a little bit of that inside.
That's not even white.
No, that's transparent. But wait. Wow. I put the solution and I mix a little bit.
Okay, now we're talking. Now we're talking. What happened? I mean, the stuff you put in the first thing did some kind of chemistry with the other stuff, or?
Yeah, in fact, the first time when I had the powder and the water, so we create like a complexation. So the water reacts with the copper, which was in the white powder. Now I add a base. You know what's the base?
I have no clue.
No. Maybe do you cook?
Yes, I do.
You cook. So when you, yeah, you're French, of course. So maybe you cook. So you have something which is sweet. What's the opposite of sweet?
I would say salty.
Salty. Yeah. Inside that. So you have the sweet and the salty when you cook. In chemistry, you have the acid. So for example, it's the vinegar or the lemon, so it's kind of acid. And the other side, the opposite, is basic.
Okay.
In this case, I just add something basic, and it reacts with the copper, and this basic thing really likes the copper. So that's why that will create a precipitation. That means two materials will react together to create a solid, which will be white and which will precipitate. That means it will go down to the bottom of the glass.
And that makes the milky stuff.
Of course.
I understand
right.
everything.
Yeah. But I think I have something else which will be also very nice.
Okay, what's this stuff? It's
Want to smell?
color? I don't really want to have that.
The stuff is called ammoniac.
Ammoniac. Oh, that's the stuff from the rotten fish.
Yeah.
Wow.
If I put a little bit of ammoniac, you see the color change?
That's beautiful.
And the milky stuff disappear.
Amazing.
Yeah.
I didn't know chemistry could be this amazing.
Yeah. In fact, what happened in this case? So the ammoniac stuff, or the ammoniac compound, likes even much the copper. So it will really love the copper, it will squeeze the copper, and so it will create some bonds. And that's why it will react to the copper, and we will have some blue solution.
Nice, and there is no powder anymore, so basically it stole all the copper that was in the powder to turn it blue?
Exactly.
Okay,
Right.
that's gorgeous. I think it reminds me of a very nice chemistry reaction. Do you know the clock reaction?
Yeah, of course, yeah, I know.
You know it?
You want to try?
Yes.
So the problem is that we need some. Did you came with friend or because we need
of
some
course.
person?
I came with some friends.
Yeah.
I'm going to grab some friends. You're my friends. Why don't you come on the stage with me? All the three of you, and all the two of you. Come.
So, but wait a minute.
Okay, what do we have to do?
Yeah, I will explain you everything. You ready? So, what you have to do, it's in the other side. So, I will make a countdown, from 3 to 0. At 0, you have to pour the plastic glass totally in one shot and the glass like that.
So you understand English, right? I didn't ask. I mean, you're my friend, so you understand English.
So you have to pour at 0, not at 1, not after 0, but really at 0 in one shot. You pour everything, and so you will have each person, each brave volunteers will have 2 glasses, and at the same time you have to pour the glasses. So these plastic glasses in the one glass.
Come next to me, and next to each other. You take 2 glasses. If I understood everything, okay. Just be ready. So it's not dangerous, right?
It's not dangerous.
Perfect.
You don't need gloves. You don't need goggles.
Okay. So you take the 2 glasses, and we will make the countdown. So 3, 2, 1, 0. But you don't do it now, okay?
No, not at 1, not after 0, at 0. Okay?
Okay.
Let's go. So 3, 2. Thank you again to the brave volunteers. Was it cool? Did you like it? Yeah, thank you.
And
So maybe now we can explain what happened now?
maybe they have an idea what happened here, right?
You have an idea?
You have no idea? Well, I think we'll explain everything on the screen. So I will walk you back to your seats. Thank you so much for joining us.
Thanks again.
Can I put them again? Oh no! Oh, no. Okay, do you expect me to understand that?
It's true, it looks a little bit complicated. Are there some chemists in the audience or no? Not really. No. Maybe you can simplify that now?
Huh?
Maybe you can simplify the explanation?
Please.
Yeah.
Yes. Okay, better.
But I think you told me you knew direction, so maybe you have an idea what happened.
Maybe. Yeah. Okay. Yeah. I think I remember.
Yeah.
So we mixed two stuff, product A and product B, and when we put them together, something happened. They made a third compound, but yeah, something happens with this one. Immediately, right away, the blue reacts with the green that was on the top right to give the red. And we have in there something that detects this red stuff, right?
Yeah, you're right.
Okay. But that was the fast one.
Yeah.
Now the slower one. So for the slower one, we put much more in. In fact, it looked like everything was the same, but there was much more of the product A. And once in presence of the product B, and we mixed it, product B took its time, consumed all the product A, consumed all the yellow stuff. This took time, a lot of time, you noticed. And it's only when all the product A reacted that finally it could give way to our last product after a very long time.
But are you sure not chemist?
Huh?
Are you sure not chemist? Because you know everything. What happened? Why?
I think I got an illumination from your explanation. So I think the only thing I have to tell you is vielen Dank für dieses schöne Experiment.
Und dann
Und Prost.
Thank you.